Hey again, Honors Chemistry. Miss me yet? Anyways, here is a video on mass and volume by displacement and interpreting those graphs that we have decided are density graphs. So first I want to talk about, and I may have mentioned this at the end of class on Tuesday if we had time, just this idea of volume by displacement. If not, this will be a refresher or a first thing. You will definitely be, I'm going to put a star next to this. This is definitely quiz test questions. Okay, so we have this unknown metal. I don't know what it is. And I have a mass, and it's 193.2 grams. Well, if I have a graduated cylinder and it says it's up to the 50 milliliter mark, what I can do is if I put my object in the graduated cylinder, the water will be displaced by a certain volume, right? And I'm going to call this volume by displacement. And so what happens is once I put this object in here, it takes up space. It takes up space just like the liquid water takes up space. And a combination of the two give them a new volume. So my volume before I added the object was 50 milliliters. The volume after I added the object was 60 milliliters. So the way I do this is I do an after volume. I'm going to make this subscript. An after volume minus a before volume, and that's going to equal to my volume of the metal. Okay, and so that's going to be equal to my volume of this unknown metal, and that's what we call volume by displacement. So my volume after was 60 milliliters, so 60 milliliters, and my volume before, I'm going to probably make this a little bit smaller, my volume before was 50 milliliters, so 50 milliliters, which means my difference or my volume of my unknown metal by displacement is 10 milliliters. So make sure you know something like that in the future about how to get volume by displacement. Usually we do it for irregular shaped objects or objects in which calculating the volume would be a little annoying. And especially with objects that tend to sink in water, which is a big hint about its density. So just a quick recap again, I usually have a volume of some amount of water or liquid that I know, and then I add my object to it, and the water is displaced, and the water is displaced by the same volume that this object is supposed to take up. And so the way I would calculate it is I get my after volume, and I subtract it from my before volume, and I will get my volume of my metal. Now, density, if you remember, density is a unit of mass in grams over volume in milliliters, right? It represents how much mass there is per volume, okay? Now, I have a mass of the metal right here. Oops. I have a mass of the metal right here. I'll highlight that. I have a mass of the metal, and I also have a volume of this unknown metal. So what I'm going to do with these two numbers is if I take mass and I divide it by volume, I should get my density. And so I take my mass, which is 193.2 grams, and I divide it by my volume, which is 10 milliliters. And if I do this math on a calculator, I should get a density of 19.32 grams per milliliter. And that is how you can do a quick rough solve for the density of an object. If I take its mass and divide it by its volume, right? So I can make a note, mass divided by volume is equal to density. And you may want to make a note of this in your notebook somewhere, or just so you have it, because you will be responsible for understanding this on your test or future quiz. So then now I have the density, which is 19.32 grams per milliliter. What if I want to identify it? Well, here is a table of known substances and densities. What I could do is I could write my density here. Density is equal to 19.32 grams per milliliter. And I could try and match up the densities in the table with the density that I calculated. So if I look at my table, I'm looking for something that has a very similar density. So it's not going to be up here. Oh, right here, gold. It looks like the density of gold matches the density of my unknown object. What we could say here is that density is a specific characteristic property of all substances. I can use density to identify an unknown. And we just did that. It looks like, I'm going to write this up here, it looks like my unknown is gold. Therefore, this must be gold. The density that I calculated matches the density in the table. Now, I want to make sure that we're good for interpreting graphs, and I carried over that density table. I have another unknown substance, right? So let me plot this data quickly. So insert, I put it into a chart. I changed the column chart to scatter plot. Oh, didn't do it. I changed it to scatter plot. Customize that, and I want my horizontal axis, do not treat it as labels. And then I give my trend line, and I throw my equation and r squared. And it looks like, and I'm going to write this on the side, that my equation of the line is y equals 10.5x plus 0. And remember, I don't have to write plus 0. That's kind of too identified. So I could just write y equals 10.5x. And then remember, my y values according to my graph, my y values are my mass, equals mass in grams, and my x values are equal to my volume in milliliters. Oh crap. Are equal to my, I have to just undo. Oh, darn it. There we go. Are equal to my volume, is equal to my volume in milliliters. And so the way that I could physically represent this equation is grams is equal to 10.5 milliliters. 10.5 times milliliters. Okay? Now, something that's huge to remember is this 10.5, that is my slope. And if you remember from a previous video, the slope of a graph of mass versus volume is the density. All right, and you're going to have to know this. I'm bolding it. You're going to have to know that if I have an equation for a line, and I look at my slope, it doesn't matter what my b-intercept or y-intercept is. If I look at my slope, that slope is the density. So that means the density of this unknown is equal to 10.5, and the units are grams per milliliter, right? So I'm going to say units for density are always a mass per volume. So it could be grams per milliliters or grams per centimeters cubed, okay? And remember, we proved recently that 1 milliliter is equal to 1 centimeter cubed. So I could interchange milliliters and centimeters cubed and it means the same thing. So anyways, it looks like the density of my unknown is 10.5 grams. I have this table down here, and I have this table with known densities. If I look on this graph, let me see if I could identify my unknown. Oh, right here, 10.5. Oops, I don't want to do that. It looks as though my unknown is silver. It matches the density. All right, so this must be silver. Now, what if I wanted to use this equation or use this graph and I said that I had, let's say I had 45 milliliters of silver. What is the mass? Let me see if I could prove that with the graph, and then let me see if I could prove that mathematically. So on the graph, if I want to find where 45 is, here's 40. This is 50. So in between 40 and 50, it would be somewhere right here on the graph. And I'm not really going to draw on the graph, but if you could see where my line is, it looks like it's somewhere by like 480 or 490, right? I'm just kind of estimating that this would be about 480, 490. So I'm going to say with the graph, I'm going to say about 480 milliliters. Oh, sorry, grams. Sorry. So if I'm looking at my graph, I go over to 45 so that this is 50. I'm going to go in half of that. This is 45. And then I'm going to go over to my y-axis and kind of estimate where that is. And I'm going to show you that in another video on paper. I have another video in which we do more calculations with this, so don't worry if you can't see it. Now, if I want to do this mathematically, I have an equation. I have an equation right here. I'm going to make it even larger. It says that my grams are equal to 10.5 times my milliliters. So if I want to solve for grams, I just have to do 10.5 times the milliliters that were given to me, which is 45. And if I do that, if I do 10.5 times 45 on a calculator, 10.5 times 45, I get about 472.5 grams. By the way, I want to make sure that we start associating units with, and we'll do that very soon. I'm going to put kind of like a box around this. I want to make sure we start associating units with our density. Instead of me saying 10.5 times 45, I should really say 10.5 grams over milliliters times milliliters, and I will end up with grams. Okay, so that is how, and that would be a question you're going to see in the future where I prove it by showing it on the graph, and I literally just kind of went over and I got about 480, and mathematically I got 472.5. Now, there's a lot of error with me kind of guessing at the graph. I get a much better value by actually doing the calculation. Now, what if I didn't want to get volume? What if I wanted the mass? All right. What if I was given the mass and I want to go for volume? All right. So let's say I have a mass of 500 grams. What is the volume in milliliters? Or even I could say centimeters cubed, which is the same thing. Well, I could do what I said before. I could do it graphically, or I could do math. And so if I look on the graph where 500 grams is, if I go over to where the line hits, I want to do it where it hits the line, right? So I go over from 500 and it hits the line at about here, if you get where my arrow is, and I'm going to go down. And it looks as though it's a little bit less than 50. So maybe I'll say it's about 48. Okay, so I'm going to say about 48 milliliters. Okay, now if I want to prove this with math, I know this equation is grams is equal to 10.5 grams per milliliter times my milliliters. Well, I could rearrange this equation to solve for milliliters. I want to solve for milliliters. Okay, so if I want to solve for milliliters, I probably want to get this 10.5 out of the way. I'm going to make this blue. I want to put this on one side, and I want to make sure that it's on the side of the grams, which is blue, which means I probably want to divide my grams by 10.5. And I will get that answer will be in milliliters, right? So this is if I want to solve for volume. I rearrange the equation. I solve for volume and rearrange the equation. It's looking like I take my mass and I divide it by density, and that will give me my volume. Make sure that's another way of us knowing that. And I'm hoping you rewatch this video so you get that. So if I want to calculate this, if I have my mass is 500 grams, and I know that my density before is 10.5, 50 divided by 10.5, I should get my volume in milliliters. So I'll do this. 500 divided by 10.5, and I get about 47.6 milliliters. And that actually is very close to the answer that I had guessed up here. I said it was about 48 milliliters on the graph. Okay, so use this video to work on handout number 2. Handout number 2 asks you to do volume by displacement and interpret a graph and solve for how to get mass and volume and density directly from a graph. And then the last thing, and I'll show you in a future video, is it's going to ask you, if I give you a density, like let's say I give you the density of mercury, how do I plot this on the graph? So I'm going to make a separate video about that. Alrighty, hopefully this helps. If you have any questions or concerns, please let me know.